In this video, we're going to be working with fractions that have a radical in the denominator, and you're going to learn how to rationalize the denominator. So for example, if we have 1 over the square root of 2, notice how the denominator has a radical in it. And if we want to write this in its simplest form, a fraction cannot have a radical in the denominator if it's in its simplest form. So we need to take that out. And to take that radical out of the denominator, it's called rationalizing the denominator. Now, in order to actually rationalize the denominator, we're going to multiply this fraction by the square root of 2 over the square root of 2. Okay, and the reason why we do this is because it allows us to actually get rid of the radical in the denominator, and you'll see that after. But the value of this fraction here, root 2 over root 2, it's just 1. So it doesn't change the value of this original fraction, but it just allows us to get rid of our radical in the denominator. So what happens here is when we multiply them, 1 times root 2 is just root 2. And in our denominator here, root 2 times root 2 is actually just 2, the number underneath the radical. And that's really just by definition. So to see that, the square root of 2 multiplied by the square root of 2, well, that's really root 2 squared. And that square essentially cancels out our square root. So the square root of 2 multiplied by the square root of 2 is just equal to 2. So 1 over root 2 in its simplest form, after we've rationalized the denominator, is just root 2 over 2. Notice how there is no longer a radical in that denominator. So let's try another example. If we have 3 over the square root of 5, so again, we have a radical in the denominator, we're going to rationalize the denominator by multiplying that fraction by root 5 over root 5. Okay? And in order to do that, that just becomes 3 root 5 over, so root 5 multiplied by root 5 is just 5. So our answer here is 3 root 5 over 5. Now let's try another one. What if we have 4 over root 12? Okay, and I want to write that in its simplest form. I can rationalize the denominator right away, but if you notice, that root 12 can be simplified a little further here. So knowing our multiplication rules with radicals, we can turn that root 12 into root 4 times root 3. Okay, and the square root of 4 is 2, so this is going to be simplified to 4 over 2 root 3. Okay, that fraction here, 4 over 2, that can be reduced to 2. So we're going to turn that into just 2 over root 3, but we still have a radical in the denominator. In order to get that out of the denominator, we need to rationalize the denominator by multiplying this fraction by root 3 over root 3. That allows us to get rid of that denominator, so we're going to have 2 root 3 over 3. So let's try a different type of example. What if we have 4 over 1 plus the square root of 5? Okay, we do have a radical in the denominator, and we need to take that out of the denominator by rationalizing the denominator. But in order to do that, we're not going to just multiply by the square root of 5 over the square root of 5. We need to multiply by something called the conjugate. And we need to multiply by the conjugate because it's not just the square root of 5 that's in the denominator. There's also a plus 1. So we're dividing by a binomial. It's not just a square root of 5, okay? And the conjugate of 1 plus the square root of 5 is actually 1 minus the square root of 5. So the conjugate has the exact same two terms as the original, but instead of a plus sign, it has a minus sign. So your conjugate will always have the same two terms, but the opposite sign in between the two terms. So going back to our example, to rationalize the denominator in this case, we're going to multiply this fraction by 1 minus the square root of 5 over 1 minus the square root of 5. So we're multiplying by the conjugate. So when we multiply this, our numerator is just going to be 4 minus 4 root 5. So we need to distribute there. And our denominator is 1 plus the square root of 5 times 1 minus the square root of 5. Now I want you to look at the denominator. Does the denominator look a little bit familiar to you? Does it look like a difference of squares, or really does it look like the factored form of a difference of squares? We have these same two terms in each binomial, but there's a plus sign in between your terms in the first binomial and a minus sign in between the terms of the second binomial. This is definitely factored form of a difference of squares. So just to remind you about a difference of squares, if we have x plus y multiplied by x minus y, so we got the same two terms, one is plus, one is minus, and we wanted to expand that really quickly, that would just become x squared plus xy minus xy minus y squared, okay? And plus xy minus y, those cancel out, so this is x squared minus y squared. And that's our difference of squares. So if you can easily identify this, you have your first two terms that are the same, your second two terms that are the same, and one binomial has a plus, one has a minus. It doesn't matter the order. You can expand this really quickly. So you take your first term and you square it, minus your second term squared, okay? So looking at our original question, we have 1 plus the square root of 5 times 1 minus the square root of 5. This is definitely factored form of a difference of squares. So we can expand that denominator real quick. It's just going to be 1 squared minus the square root of 5 squared. Okay, and to simplify that, our numerator is going to stay the same here for now, and our denominator just becomes 1 minus 5. And again, to simplify that, 4 minus 4 root 5 over negative 4. And we can actually reduce this even more because in each term on the numerator we have a 4, and we also have a negative 4 in the denominator. So if we take 4 divided by negative 4, that is negative 1. Okay, and negative 4 root 5 divided by negative 4, that's just going to become plus root 5. So let's try another question. If we have 3x over 2 root x minus 7, we have a radical in the denominator, that's the 2 root x, and we can't have that in the denominator, so we need to multiply by the conjugate to rationalize that denominator. So our conjugate is in this case is 2 root x plus 7. So we're multiplying by 2 root x plus 7 over 2 root x plus 7. So let's multiply these. In the numerator, we need to distribute. So 3x times 2 root x is just 6x root x. And 3x times 7 is going to be plus 21x. And in our denominator, we have a difference of squares. So we can do that real quick. So we can square that first term, 2 root x, and it's minus the second term squared. Okay, so we can simplify that. I'm not going to worry about these powers on our x and root x. You can simplify that, but the purpose of this question was just to rationalize our denominator here. So I'm just going to keep this as 6x root x minus 21x, okay? And we got to square those terms in the denominator. So if we have 2 root x squared, we want to square this coefficient at the front. So it's going to become 4, and by squaring root x, we're just left with x. And this is going to be minus 7 squared, which is just 49. As you can see, we no longer have a radical in our denominator, so we have successfully rationalized this denominator.